us talk. Then people can hear us, and now you press that button too, and then they can see us. Hi, good morning. So we have a very exciting panel here for you this morning. We have Dave Lavery of NASA fame, who is going to be answering all of your children's pressing questions about space exploration, solar system exploration. And I know Mason has a question that she's dying to ask. I think West has a question. Before we dive into that, I just wanted to acknowledge that people have been toiling away on their items for GISH for the last 12, 18, 16, I don't know how many hours. And we have a few items that we can showcase for you. So let's see, I want to show you some of these items. Hold on, see if I can figure this out. There we go. Oh my goodness. This is the paperclip jewels that make Queen Elizabeth jealous. Item number 50. That is truly extraordinary. Mason, do you think that we should send these guys some jars of jam for their hard work? We're gonna send you guys some jars of our homemade quarantine jam as a reward for your exquisite work there. That is actually quite stunning, isn't it, Mason? Isn't that amazing? That's made out of paper clips. Let's look at a couple more. Oh, this is getting your grandparent to teach you a skill, and this looks like your grandmother's probably teaching you how to be a card shark of some sort. She looks like a serious gambler. That's fantastic. All right, let me find one more. Oh, this is too good. Hey, Westy, you have to see this castle. This is fantastic. Wait, what is the item? I can't quite read it. Right, it's the fairy castle for a child's imagination. Westy is right now working. He's right over here in the corner. Maybe you can see him, the piece of him.
I was just bandaging Hazel's paw.
He's working on his castle too. Look at that castle, pretty rad, huh?
What is it made out of?
Well, I don't know. It looks like it's made out of cardboard and construction paper and some other things. All right, let's go talk to Dave and ask our questions about space. Oh, that is phenomenal.
Why are we?
That's
Who are you
coffee
talking
grounds
to?
and pencil shavings in a portrait of Jared Padalecki. That is really beautiful. Wow. All right, let's find Dave. Let's talk to Dave.
Why are you on the phone?
Let's talk to Dave.
On the phone. Who are you talking to?
Hi.
I hear someone talking.
Wait. Hi.
Good morning.
Good morning. How are you? Oh my God, you're actually on the surface of Mars right now.
Hey, somebody has to be. It's me and the robots.
That's amazing. It's not a background. Come on, he wouldn't. You're a space guy.
Then how is he not wearing a helmet?
He has a lot of practice on Mars. He's just fine.
I'm holding my breath while I talk.
No, you're not.
Can I tell a quick story? So Dave and I met up to say hi in Washington, D.C. with West when West was maybe 3, I want to say.
3 or 4, yeah.
And you brought with you the smallest portable satellite that was about the size. It was a real satellite. It was about the size of a beach ball, which you had the opportunity to hold, and you held it, and then you dropped it and kicked it. And I was like, no, NASA's gonna come for us.
The first interplanetary soccer ball.
So, David, my children have a couple of questions for you about the solar system. And then maybe we could have some other kids ask questions as well. And so if anyone who's watching right now has kids and questions, just raise your hand and we'll bring you in to ask questions. Okay, what is your question, Westy?
Nothing.
No question.
Wait,
Westy,
yes,
Westy
yeah.
dressed up special for the event. I don't know if you
I was
know
gonna say I like this the shirt. That's awesome.
sweatshirt.
Have you seen a picture of a black hole, and do you think there's life on Europa?
Okay, so have I seen a picture of a black hole? Yes. They actually just took the first real picture of a black hole this past year and got it published. And so we actually begin to have an idea of what one really looks like, or at least what the area around it looks like. You can't see the black hole itself because, well, it's a hole and it's black and there's not much to see. But you can see the area around it. It's something called the event horizon. And we got a picture of that, which was very cool. And is there life on Europa? That's actually a really, really good question. That's one that we're trying to figure out. One of the projects that I'm working on right now is a mission called Europa Clipper that is going to send a spacecraft to survey Europa and look at what we think is a really thick crust of ice with potentially a water ocean underneath it. And there is the potential, if all the things are right and all the little bits and pieces are lined up properly, in that water ocean under the ice crust of Europa, there might be life. And one of the things you might want to think about is if there was life on Europa, which is basically just an ocean covered with ice and it's always been ice covered, what would the life look like? Would it be just like fish? Would we go and find just basically giant interplanetary trout? Or would it be something completely different? And that's something we're all sort of wondering.
Okay, do you think there is life on Europa?
Do I think there's life on Europa? I don't know. I think it'd be amazingly cool if there is. I think all the environment and the climate and everything else is got all the right ingredients to support life as we know it. I would actually kind of hope that there is, because I think that would be amazingly cool to know that we're not the only ones in the universe, and that would be a great way to prove it. But I don't know for sure yet. We haven't seen enough evidence yet. I don't know.
Mason, do you have a question? Here, wait, Mason's going to ask one question, and then we have to take advantage of our moment in the spotlight here.
Can you, is that like they send like worms into outer space?
Okay, I couldn't quite hear your question, Mason.
A little louder, Mason.
Okay, I heard that they sent worms into outer space.
Over the years, we've sent all sorts of different things into outer space. Obviously, we've sent people. We've also sent lots of different animal experiments into space. We started off, actually, before we ever launched the first people, we launched monkeys. And the Russians, way back in the beginning of the space program, they launched dogs into space. But over the years, we've launched all sorts of stuff. We've launched worms, we've launched frogs, we've launched spiders. I think we've launched bees, because we wanted to find out, for example, how does a spider make a spider web in zero gravity in space? And it turns out they do wonderfully. They take a little bit of time to adapt, and then they just go on. They spin their webs the way they always did. We've had frogs in space. We've had, like I said, bumblebees in space. We wanted to find out how they would build their nest in zero gravity. And so we've had, lots of different animals over the years have gone up and been able to fly in space and become astronauts all by themselves.
Wow.
And
Wait,
I heard that
wait.
they they chopped off like their heads, and then it grew back with two heads.
Well, you're in there.
Grew back with a head on each side, or two heads on one side. Two heads on one side.
Well, I'm not sure. That part I didn't hear about. So I don't know about that, about chopping off the heads of them and having two heads grow back. I would have to find out some more about that.
All right, well, we can do research on that question. All right, we'll let some other kids ask some questions now. You have a question there?
Yeah, Lucas here. Say hi.
Hi, Lucas.
He was wondering how you felt about the whole Pluto debate, because he was pretty upset about it.
All right. Well, so when I grew up, Pluto is a planet, and so I'm still sort of stuck on the idea that, you know, it was a planet when I grew up, and as far as I know, it didn't change. And there's all been these other people debating about, did something change in the definition enough to say that it's not a planet anymore? I'm not part of that group, and so I don't get to have a voice in that. But for me, I always learn 9 planets, and 9 planets it is. And so because otherwise I can't remember them in order if I don't end up saying that Pluto is the last one. Now that's also only true until we find another one, and then we find out that there's 10, and so that'll mess up the whole count again all over anyway.
Perfect.
What's your
Thank you.
question, Maida?
What is Mars like?
What's Mars like? Okay, really, really good question. So here's just a couple of things really quick. So Mars is about half the size of Earth. It's really, really cold. And by really, really cold, I mean it's in the middle of the summer at the equator, where on Earth it might be like 100 degrees Fahrenheit. On Mars, at its very warmest, it'll be 60 or 70 degrees Fahrenheit. But then at night, in the middle of the winter, at the equator, it can be 150 degrees below zero. So it's really cold. The atmosphere is really thin. It's about 1% as thick as the atmosphere on Earth. So if you were on Mars and if you could breathe that atmosphere, it would be like standing on top of a 100,000-foot tall mountain on Earth and trying to breathe. It's so thin. But it's really, really bright. Because the atmosphere is so thin, it doesn't filter out most of the sunlight. And so most of the sunlight gets all the way down to the surface. So standing on the surface of Mars would be like standing on the equator in the middle of the summer at noon on Earth. So really, really bright. And the one other thing about it that's kind of really cool is the gravity on Mars is only about 1/3 the gravity on Earth. So if you weigh 90 pounds on Earth, you only weigh about 30 pounds on Mars. So it's one of the best diet programs anywhere.
Hey, Dave, it's Charlie.
Hey, Charlie.
How are
Hi,
you?
Charlie. Hi, Finn.
Hi, Misha. This is my son, Finn. He had a question for you real quick.
Okay.
It's what planets and moons in the solar system are most likely to have life on them?
So that is, it kind of depends on how you define life. And one of the things that we're figuring out just about Earth is that pretty much everywhere we look on Earth, we find life. We used to think it only existed in really sort of warm, calm, benign environments, but it turns out that there's life on Earth everywhere we look. And by that, I mean, we find life on Earth 20 miles down inside solid rock. When we drill down deep, make very, very deep drill holes, we find life inside nuclear reactors on Earth. And so all these places where we thought life could never exist, it turns out it does exist here on Earth. So what that means is that if life is somewhere else in the solar system, it might exist in places that we normally would have thought were not very hospitable. So we're starting out at looking at places that are as Earth-like as we can find, because we think that's probably the best chance for it to exist. But past that, we're not sort of stopping there. We're looking at all sorts of different places. Anyway, the top 2 places we're looking right now are Mars, because Mars was once very Earth-like. It was warmer and wetter than it is now. We think that that might have been a place that life could have got started. And the other place that we're looking is one we've already talked about, Europa, because we think that Europa possibly has a liquid water ocean today. And if it does, then it's got water, it's got warmth, it's got chemistry, it's got energy, all the key ingredients for creating a place where life might exist. So those are the 2 places we're looking first, but then we're looking at the rest of the solar system too, because it turns out that life is so extreme on Earth that it can exist almost anywhere. So it might exist almost anywhere in the solar system.
How far away can the average human get from a black hole without being sucked in?
How far away can a human being get from a black hole without being sucked in? That really depends on the size of the black hole, because they are all different sizes. And so it is a sort of thing where, depending on the size, you reach this thing called the event horizon from which nothing escapes, and you would sort of fall in and get sucked into it. But realistically, it would be extremely dangerous for people to the point that they probably wouldn't survive much farther away than that, just because of the enormous gravitational pull. You actually would get pulled apart by something you're actually used to here on Earth, the forces of the tides. That basically, just as you swung around a black hole, even far away from the event horizon, the tidal forces from the gravity would be so strong, even across a short distance, like from your head to your feet, that it would probably cause you a lot of problems.
Say hi, Tristan.
Oh, hi.
Hi.
You have a question?
I thought of one. How many rovers have you sent on to Mars?
So far, I've worked on 4 different rover projects. The first one I ever did was a Sojourner rover, which was part of Mars Pathfinder in 1997. And then I worked on Spirit and Opportunity that landed on Mars in January 2004. And I'm working right now on the Curiosity rover that's on Mars right now and landed in August of 2012. And we're about to launch a 5th rover to Mars that will go up this July, which is Perseverance, which is sort of the twin sister of the Curiosity rover, a different science paper, but the rover itself is very similar. And it's actually going to collect a bunch of samples that later missions will pick up and actually bring all the way back to Earth. So it's the first part of our Mars sample return campaign. So anyway, I've worked on 4 that are there now, and I'm working on the 5th one, and there's actually a 6th one that we're working on with the European Space Agency that will be launched in 2 years.
That's cool. Who names them? Who names the rovers?
Morning. Where are you in the world?
Tristan, where are we?
Yeah, you're unmuted.
Come on, can you talk?
Ow.
Yeah, Elle?
We're in Southern California.
Oh.
So I know it's kind of a theory, but do you have any evidence of the white hole on the other side of black holes?
That is a theory that people have talked about a little bit, but we haven't seen any evidence of it, any proof of it yet so far. That's one of those wonderful things that people sort of think of neat ideas, and that the laws of physics say this might exist, but we haven't actually found any data yet to show that it actually has happened.
Is that Tom and Shep? Hi, guys. How are you?
Good.
Hey, Jen.
Hi.
What are you? Where you guys? It's so beautiful and sunny where you are right now. Are you in your backyard?
We are. We're outside. It's
Nice.
it's like 80 degrees today. It's finally nice and warm out.
Wow. Wow. Do you guys have any questions about space?
Come on.
No.
We've just been working on a NASA spaceship that we built out of cardboard in the backyard, huh?
What?
I don't have any questions. Remember the star that you were looking at last night? You were asking about like why it was blinking. Are you guys getting shy?
No.
Well, that's a good question. Why do stars twinkle when we look at them?
So when you look up at the sky, the ones that are twinkling, those are really stars. And you'll see that there's some of them that actually don't twinkle at all. They just sort of stay constantly bright. And usually that means that that's a planet a lot closer. The reason that they twinkle is they're not actually twinkling. They're just like a light bulb that stays on really bright all the time. But what happens is the light gets disturbed as it comes through our atmosphere. And what you see are the effects of our atmosphere moving around and distorting that light just a little bit. And that's what causes that twinkling that you see from the starlight. All right, now I have a question for Misha. Do you know, so the sun is actually a star. We all know that. Do you know why the sun went to school?
Because it wasn't that bright?
He wanted to get a little brighter.
Ah! I guess that's not a good message to be sending to kids. You only go to school if you're not that bright is not the right message to be conveying, is it?
Right.
That's a very good question. That's a very good science space question. Yeah. Should we, anyone else have any more questions? So nice to see you, Tom and Shep.
What do you say? So good to see you, Misha and Mason.
Good to see you.
Good to see you.
Lizard. They brought their friends with them. I don't know if you can see, but you want to show
Your
them?
what?
We have a question.
Oh my gosh. That's a lizard. Wow.
Yeah, lift it.
Wow.
Over high.
Oh, did they catch those?
Are you guys gonna eat those later?
Nope.
Put them on the barbecue.
Should any other kids here have a question?
What's your question, Lil?
What type of school do you have to go to be an astronaut?
Oh, okay. A really good question. So it used to be a long time ago that the way you became an astronaut, this is like really right in the beginning of the space program, that you had to go to school and get a technical degree, and then you became a pilot, usually for the military, and you had to be a military test pilot flying high performance jets. And that was the only way you could become an astronaut back in the early days. But things have changed a lot since then. And realistically right now, if you wanted to apply for the NASA Astronaut Corps, usually what they're looking for is an advanced degree in one of the sciences or engineering. So you might go and you may get a degree in chemistry or biology or geology, or one of the engineering sciences, be an electrical engineer or mechanical engineer, something like that. Usually are the sort of backgrounds that we're looking for a lot of our astronauts. Or you can still be a pilot, a military test pilot. It helps always. And those are the type of skills we're looking for a lot of our astronauts. But things are also opening up a little bit. So a lot of other professions that you might not think of are also places where you can either be an astronaut or just come to work for NASA in some of the other roles that we have. We have almost every profession you can think of working for NASA. We have journalists, we have nutritionists, we have cooks who actually figure out what's the right food that can exist in space and be nutritious in space that gets launched and stored on space station for a month or two before the astronauts eat it. We have artists, we have musicians, we have writers, we have computer programmers, almost everything you could think of, every profession you could think of, we have working for NASA, one place or another. And so it's really the important part is that you go and you get a good education, you go to school, go to college and get a degree in something that you enjoy and that you have fun with and you look forward to working with, and we can find a place for you.
Awesome. Thank you.
Hi there. Where are you guys?
South Wales in the UK.
Wow. Do you have a question about the solar system or space?
We do. My little girl's hidden now, but her question is, she's hidden. Her question is, why does the Earth have an atmosphere while other planets don't, or as much?
Great question.
Okay. Well, the Earth has an atmosphere because it turns out that most of the planets, in terms of the way we think they form, that they all, as they were all formed out of this primordial material and started to cool off, that they all started with an atmosphere. And that was just a natural production of gases that collected around the planet as the planet cooled and the rocks cooled down and sort of gave off this gas. So they all started with an atmosphere. But what happened is over time, certain planets, things happened with them that caused the atmosphere to get ripped away. For example, Mars, mentioned before, the atmosphere is really, really thin there. We think that it used to have a much, much thicker atmosphere. But because Mars is smaller than Earth, it cooled a lot faster. And so that internal liquid molten rock core that was spinning around that actually created an electric field around Mars that used to protect the atmosphere like a magnetic shield, that stopped when the planet cooled off and the core all the way to the center actually froze. And as soon as that stopped, that magnetic protective shield around Mars, it stopped. And so all of a sudden the solar wind could hit the Martian atmosphere, and very, very slowly over many, many millions of years, the atmosphere got stripped away and basically got blown away by the solar wind. And so that's why Mars's atmosphere, we think, is so much thinner now. And it doesn't have the atmosphere that it once had. But some of the other planets that have been more Earth-like, for example, Venus has a very, very thick atmosphere. It's actually thicker than Earth's. You look at some of what we call the gas giants, Jupiter, Saturn, Neptune, they're almost entirely atmosphere. And so it really all depends. It's sort of, some of them are very, very thin and tenuous. Some, like the moon, have practically no atmosphere at all. But other ones, like the gas giant planets, they're almost entirely atmosphere. So it all depends.
Hi, I think this might be our last question, guys. Do you guys have a question about space?
Do you have a question?
I don't know.
You don't know? Are you shy?
I'm thinking.
Okay.
There's just a lot of things I have a question about space. I want to.
Okay. Ask
How does the Earth spin around?
How does the Earth spin around? Is that your question?
Yeah. It's a spinning thing. Look at this.
Okay, how does the Earth spin around?
Okay.
All right, so the Earth spins around because it basically got started spinning when all this stuff in the early solar system all collected together, and all of that stuff was spinning. And as all those early rocks and comets and what later became asteroids and things, all that stuff collected and compressed itself together, it had a lot of energy, a lot of rotational energy was what we call it. Basically, that was already spinning, and then as it collected, it kept on spinning. And every time something new came in and fell into that pile of rocks that eventually became Earth, all that spinning rotational energy was still there, and it kept that whole cluster of rocks spinning around. And that's basically just as what's happened, is all that energy from way, way back, a couple of billion years ago when the solar system started, all of that energy is still there, keeping things spinning around. It was very, very slowly over long periods of time, slowing down. But that's really what it's from. It's just like when you take a top and you spin it on your table, that you give it that first kick of energy that gets it spinning, and it stays upright and spins and spins and spins and spins. But just very slowly over time, it slows down, but it keeps on spinning for a long time. That's what Earth is doing right now. That's what the other planets are doing right now, is they're still going from that first big kick of energy when the solar system formed.
Fascinating. Well, Dave, thank you so much for coming on and giving us a little education on the solar system and space this morning. I always love talking to you. You are such a fascinating and curious person, and you're so full of interesting facts. Sometimes Dave and I have these kinds of conversations that we're having here, just the two of us, because I'll call up and I'll ask him space questions. And he's always very patient with me. I look forward to seeing you sometime soon, and I hope that your quarantine is going okay. It's really nice to see your face. And it's
nice. Everything is going really well so far, and I hope you guys are staying safe too.
We are. And it's nice to see so many kids coming out this morning and asking questions about space. We have an item in this little mini hunt that we're doing right now, which is the kids they're stuck at home and they're missing science class. So they have an opportunity now for this item to make a diorama about space, about something that they learned from Dave today. And aliens are optional, so you can pepper those in if you like. All right. I mean, two-headed worms would be a good place to start, honestly.
That would not be bad. And think about two-headed worms that grow a mile under the surface in the solid rock of Mars and what that might look like. Or, actually, I sort of gave a hint before. What would life in the ocean of Europa look like? Imagine you're in an ocean that has been covered by ice for millions of years. No sunlight gets down there. It's always dark. But there's an ice roof over the top of it. And what would it look like if you lived there?
Dave, can you told me something about an asteroid hitting the ice on Europa and a thought experiment that ensued from that, and had to do with orbiting fish. Can you just tell us that as one parting story?
I will. Okay, so I'll give you the real quick version. So the first thing I'll mention, and this is somebody for you guys to all look up, a very, very well-known physicist named Freeman Dyson from Princeton University. Actually, he's the one who told me this story. He unfortunately, he passed away just a couple months ago this year. But I was having lunch with Freeman Dyson a very long time ago, and he's the one who actually told me this story, and it's one I've never forgotten since then. And it's a thought experiment where he basically said, imagine, if you will, that there's this ocean on Europa, and it's this ice-covered ocean. It's been that way for millions of years. There's been no sunlight that gets down to the ocean because the ice is so thick. It's about 10 miles thick layer of ice. But there's energy there, and there's chemistry there. There is sediment at the bottom of the ocean, and at the top of the ocean, there's this roof of ice. And the only logical leap we're going to make is that life gets started. We don't know how, but imagine that life got started. Well, if you assume that life got started, it's probably not a far stretch to think that it's an ocean. It probably develops life that looks kind of like fish. And so imagine that you're a fish living in the ocean of Europa. And all you know about your world is there's a bottom, the seafloor, and there's a top, this roof made of ice. Now, one of the things that we know about Europa is that every now and then a meteor will come in and crash into the ice surface of Europa, and it actually will impact things so hard that the ice, for a very short period of time, the ice actually cracks open. So you have a 10-mile deep crack in the ice that goes all the way from the surface all the way down to where the ocean is. And the water from the ocean fills up that crevasse very, very quickly. And somebody actually did the calculation, and I think it was one of Freeman's students, actually did the calculation that water that jets that 10-mile thick, just up through that 10-mile thick layer of ice, gets the top of that water column gets going so fast that when it gets to the surface of the ice, it actually shoots out into space. It doesn't all fall back down, but actually becomes, it does what we call achieving escape velocity. It actually overcomes gravity and goes all the way out, jetting into space. So imagine that you're one of these fish swimming in the ocean of Europa, and you happen to be the most unlucky European fish anywhere. You are just swimming right below the ice shelf when one of these meteors hits, and all of a sudden the ceiling of ice above you, and that's all you know about, cracks open, and you get sucked up inside this jet of water that goes shooting up 10 miles, past 10 miles of ice. And all of a sudden, as you get to the surface, you're in that part of the water column that gets shot out into space. And so for the first time in your existence, as you're shooting past, you see the wall of ice go past, the wall of ice ends, you go shooting up past the surface of Europa, and for the first time ever, you actually get to see space beyond just this roof of ice that is all you've known. And in your little European fish brain, you get to think, oh, wow, this is so unbelievably cool. I've just seen the rest of the solar system. And you get about that far before you freeze and die. And so all you get to see is this one quick glimpse of the rest of the solar system, and you realize there's something else out there, and then you get so cold that you freeze and die. But now you're a frozen fish sitting in orbit around the planet Jupiter, which is where Europa is existing. And you will sit in frozen European fish in Jupiter's orbit for millennia. Now, the final part of the thought experiment is we're now on the first human mission to Europa sometime in the distant future. And all of a sudden, as your spacecraft is coming into orbit around Europa and you're beginning to orbit this little moon of Jupiter, you hear this thang on the outside of your spacecraft. And you have to look outside your spacecraft, and you see embedded in the front of your spacecraft is a frozen trout that has just hit your spacecraft. And now your task is to figure out that first communication back to mission control back on Earth, where you have to tell them, there's a frozen fish embedded in our spacecraft. What are you going to tell them that will convince them that you're not completely crazy and need to be locked up somewhere?
That's amazing. I sincerely hope one day we do find fish orbiting the moon of Europa. That sounds incredible. Thank you, Dave.
Glad to do it.
Take care. See you soon.
Talk to you later. Bye-bye.
Bye.